Hey everyone and welcome. Today we're going to jump right into the world of graph databases. We're going to see how they are completely changing the game when it comes to handling connected data.
So let's kick things off with a question that really gets to the core of this whole thing. Why is finding friends of friends such a nightmare for traditional databases? I mean, it sounds simple, right? But that one little query can bring even the most powerful systems to a grinding halt.
You see, for decades, we've organized data in tables, neat and tidy rows and columns, just like a spreadsheet. And for things like customer lists or product catalogs, where everything fits into a nice, clean box, that works great. No problem there.
But here's where things get messy. What happens when you need to connect the dots between different tables? To find your friend's friends, a traditional database has to do something called a join. Just imagine having to check one massive phone book against another one, and then do it again and again, just to follow one single chain of people. Every single lookup makes it more complex and just slows the whole system down to a crawl.
And this, right here, shows you the difference in a nutshell. For old-school relational databases, finding connections is a slow, painful task they weren't really built for. But for graph databases, finding connections is what they do. It's their main job, making the whole process unbelievably fast and, well, just simple.
So that leads us to a totally new way of working. Instead of trying to cram our messy, connected world into rigid tables, we can start thinking in graphs. It's a way more intuitive model for how things actually work.
The specific model we're talking about is called the labeled property graph. Yeah, I know, it sounds a little technical, but the idea behind it is incredibly simple. It's designed to work just like our brains do, seeing the world as a huge network of interconnected people, places, and things.
Okay, so the first piece of the puzzle is the node. A node is basically just a thing, an entity. It could be a person on a social network, a company, a product you're selling, any individual object you want to keep track of. And now for the magic ingredient, the relationship. This is what connects the nodes. But here's the key. It's not just a dumb line. It has a direction, and it has a type. So you don't just know that two people are connected, you know how they're connected. Does this person know that person? Did this customer buy that product? And that brings us to this quote, which is maybe the most important takeaway here. In a graph, relationships aren't some afterthought. They are first-class citizens. They're not just bridges between data points, they're like entire highways with their own traffic data, their own rules, their own information. They are data points in their own right. The last piece of the model is the property. These are just the details that give everything context, like a person's name on a node. But here's the real game changer. Relationships can have properties too. So that bought relationship can store the date of the purchase, the price, the location, turning a simple connection into a super rich piece of information all by itself.
Okay, so that's the theory behind it, but where does the stuff actually pop up in the real world? Let's take a look at how graphs are already out there, uncovering the connections that shape our lives every day.
The most classic example, of course, is social networks. Remember that friends of friends problem we started with? Well, for a graph database, that's not some huge, complex operation. It's just a simple two-step walk across the graph. It's so easy, it's almost trivial, and it lets you map out entire communities in a flash.
Have you ever wondered how a shopping site just knows what to suggest to you? Yep, that's a graph working its magic. By following the paths, people who bought this also bought that, these recommendation engines can spot patterns in real time and serve up those scarily accurate suggestions.
And in the world of security, graph databases are an absolute game changer for fraud detection. You see, fraudsters create these complex, hidden networks. A graph can instantly connect the dots and spot patterns that are pretty much impossible to see in tables, like say a bunch of unrelated accounts that all just happen to share the same credit card or the same device. It uncovers the whole fraud ring.
And it really doesn't stop there. Graphs are being used to manage massive IT networks, to track a single product through a global supply chain, and even in biology to make sense of the tangled web of protein interactions. The possibilities, you get the idea, are just huge.
So are you feeling inspired? The absolute best way to really get the power of graphs is to just roll up your sleeves and get your hands dirty. So let's talk about how you can start your own graph journey right now.
So the go-to name in this space is a database called Neo4j,
And the absolute easiest way to get started is with their cloud service AuraDB. It handles all the messy installation and setup for you, and the best part, it has a totally free tier so you can start playing around with it without spending a dime.
And getting set up is super easy. Seriously, you just go to their website, register an account, make sure you pick the free AuraDB option, answer a couple of quick questions, and then you just hit create. In just a few minutes, you'll have your very own graph database up in the cloud, ready to go.
So we've seen that our world is basically built on connections. And graph databases give us this incredibly powerful new key to unlock all the secrets hidden in that data. Which really just leaves us with one last question. In your world, what hidden connections are just waiting to be discovered? Thanks for joining me.